Assalamu alaikum. We learned about drift velocity and mobility in the previous video. In this video, we'll discuss the microscopic model of current. For that, I have considered a conductor having area of cross section A. Here, I assume that all electrons present in the conductor travel with velocity Vd, which is nothing but drift velocity. When I say electron, I mean free electrons, which are free to move from one atom to another atom within the conductor. Suppose they move from this point to this point within the conductor, then they travel a distance of dx in time dt. Then drift velocity can be obtained by taking the ratio of dx and dt. We know rate of displacement is nothing but velocity. Now from this, distance covered by the free electrons can be obtained by cross multiplication. If we multiply Vd with the dt, we get a dx. Now here I write the value of dx here, just exactly below this. That is Vd dt. I take this one as equation number 1. Go ahead. Now we will find out the number of free electrons present in this region in the volume of length dx. I take n as the number of free electrons present in the volume of length dx. So that can be obtained by multiplying volume with number of free electrons present in per unit volume, present in per unit volume. Here volume is obtained by multiplying area with the length or distance, and number of free electrons in per unit volume is taken as a E. This gives us number of electrons in the volume element. Here volume element represent this part whose length is ds. Let's go ahead. Now we know the value of dx. I am going to substitute the value of dx from here. So for better understanding, I take this equation as equation number 2. Now I will substitute equation 1 in 2. So what I will get? I will get this. A V d dt into n. This gives us the number of electrons present in the volume of length dx. I represent this one as equation 3. Now we'll find out the total charge of electrons present in the volume element. That can be obtained by multiplying the charge of electron with the total number of electrons present in volume element. Here I take a total charge as dq. That can be obtained by multiplying charge of the electron, that is E, with the total number of electrons present in volume element. That means in this region. So total number of electrons in the volume element is given by equation number 3. This is A Vd dt into N. This can be written as dq N A E Vd dt. Right? Now this is the charge. Total charge of electrons present in volume element. Now from this current, the expression for current can be obtained by dividing it with the time. We know dq upon dt is a current. I'll substitute the value of dq from our expression Ne Vd dt, and it is present here. The same terms get cancelled here. So I is equal to NaE Vd. This is the expression for current. And it also gives the relation between current and the drift velocity. Now I will find out the expression for current density, which is denoted by letter J. It is a vector quantity, so we use the arrowhead. Now for that, I take this as equation number 4. Current density is nothing but electric current flowing per unit area of the conductor. So J is equal to I upon A. And its unit is ampere per meter square. Now I am going to substitute the value of I from equation number 4 here in this equation. I take it as equation number 5. I will substitute 4 in 5. See what do you get? So J value will be obtained something like this. J equals to NaEVd upon A. Here the same term get cancelled. A and A get cancelled, and J will be equal to NeVd. We know the value of Vd from the previous topic. Vd is nothing but Ne as such, and the value of Vd is written as E tau upon m multiplied with the E. The capital is electric field. Now, when we multiply this term with Ne, we get a new expression for J. That is nothing but J equals to minus N E square tau upon m into E. Here, the current density is a vector quantity. So, we need to include arrowhead. The same thing I do for electric field as well, because it is a vector current. I will do the same thing to previous step as well. Here, here J vector, VD vector, and here E vector. But here, in this equation, this term is known as conductivity, which is represented letter sigma. So in the place of this, I am going to write sigma. So I'll get a new expression for current density, which is something like this: J vector equals to minus sigma E vector. Now you need to remember one thing: current density always act in a direction to that of electric field. So we can omit the minus sign. This expression can be written as J vector equals to sigma E vector. For better visibility, I box this equation. And here sigma is what? Sigma is equal to N E square tau upon M. And sigma is the reciprocal of resistivity. So if a sigma is this, then rho will be written something like this. The value of rho from this expression can be obtained something like this. Rho equals to the reciprocal of sigma, that can be obtained by inverting this equation. Rho is equal to M upon N E square tau. This is the expression we get for resistivity. We have learned about resistivity in detail in the previous video. I hope this video is useful. If you have any kind of doubt related to the topic, can you put a question in the comment section. Thanks for watching.